This video is the 9th video in the complex number set of videos, and in particular in this video we're going to be looking at the modulus, which I refer to as the jacket. The modulus of a complex number represents the distance of the complex number from the origin in the complex plane, much like finding the length of the hypotenuse in a right angle triangle using the Pythagorean theorem. For a complex number z, which is a plus bi, the modulus, which is denoted as z with two lines either side, hence why I refer to it as a jacket, is equal to the square root of a squared plus b squared. This formula comes from considering the number as the point AB in the Argand diagram, and here A is the horizontal or the real part and B is the vertical or the imaginary part. In the first example, I'm going to go through exactly what I mean when I talk about this being the exact same as a Pythagoras theorem type of question, and then in example 9.2 and 9.3 I'll do more of an answer that you would be expected to give in a Leaving Cert ordinary level exam. So in example 9.1 it says find the modulus of 2 plus 2i. So first thing that I'm going to do is I'm going to plot this point, and if we plot 2.2i we'll see the point on the coordinate plane here, and I'm going to label that as z. The modulus is the distance from the origin, which I'm going to draw here with my red line. Now, if we draw a triangle from there down to the real axis and across back to the origin, we form a right angle triangle. Now, every right angle triangle has three sides, as does any triangle, but in a right angle triangle, we have our hypotenuse and we have our two other sides. Pythagoras' theorem states that if you have a triangle, and that triangle is a right angle triangle, that if we have the hypotenuse, which is the longest side, and it's most always labelled as C, and it certainly is in your formula tables booklet, then if you take the square of that side, it's equal to the square of the other two sides added. And that's what's in your formula tables booklet. However, in this side, we're not looking at c squared. We want to figure out what the length of that side is. So, although this is c squared, we want c. So to get c, we get the square root of the other side. So a squared plus b squared. If you're given a right angle triangle and you want to figure out what the hypotenuse is, you need to know the value of a and b. And if you do, then you use the square root of a squared plus b squared, and that will give you the length of side C. And that's exactly what we're doing when we find the modulus. We use the formula, the square root of a squared plus b squared, for whatever complex number we have. So here, when we want to find the value of the red line, we find that using the formula, the square root of a squared plus b squared, where a is the real number and b is the imaginary number. And in this case, they're both the same, but a is the distance, we're going to say, from 0 to 2 along the real axis, and that's 2. And then b is the distance along the imaginary axis, which goes from 0 up to 2 as well, which we can see there is 2. Writing down the formula then, we have 2 plus 2i, and if we want to find the modulus, it's the square root of 2 squared plus 2 squared. 2 squared is 4, and 2 squared is 4, meaning we end up with 4 plus 4. That gives us 8. We can rewrite the square root of 8 as the square root of 2 multiplied by the square root of 4, and that will break down to give us 2 root 2. Just to recap what we've done in this question, we found the modulus of 2 plus 2i, which is 2 root 2. But what that stands for is the distance from the origin to the point 2 plus 2i on the Argand diagram. Example 9.2 says, determine the jacket of z for z equal to minus 3 plus 4i. Again, just to show this so that you can visualize it on the Argand diagram, the complex number minus 3 plus 4i will be plotted here. And this is our z. We're looking for the modulus, and you can use the formula for that, and the modulus of z is going to be equal to the square root of a squared plus b squared, Remember, the modulus is the distance from the point to the origin on the complex or the argon diagram. Here we have the complex number z equal to minus 3 plus 4i. Therefore, a is equal to minus 3 and b is equal to 4. The complex number will then give us the modulus of negative 3 squared plus 4 squared. This then will break down and we'll get 9 plus 16, which will give us 25. So then the modulus is going to be equal to 5. So the distance from the complex number z to the origin is 5. Example 9.3 asks us to calculate the modulus of the complex number z equal to 5 minus 12i. Here we're getting the modulus, and the modulus is just the square root of a squared plus b squared, where a, this case, is going to be 5 and b is going to be minus 12. Make sure you bring the sign always. So if it's negative 12, take the negative sign, or if this was minus 5 minus 12i, you'd bring the negative sign with the 5 too. Therefore, for this one, we have the square root of 5 squared plus minus 12 squared. That will give us the square root of 25 plus 144, which gives us the square root of 169, which means the modulus is going to be 13. So again, the distance from the origin to the point 5 minus 12i on the argon diagram is 13 units. That brings us to the end of this video, where we were looking at the modulus of z, or z jacket, where we get the distance from the point, which is usually z, to the origin 0, 0.